Let me talk about my new application and I'll just test it. Hello everyone, I have created my application which is Ayurlekha. The name Ayurlekha, Lekha is uh, history and Ayur is used for medical. So it is AI powered medical history assistant. The whole idea behind it was the user, basically the patients, which we all are, uh, can just upload a document. That's it. But what they get it, the documents we are talking about, it can be any medical document in any order of any given time. But what user will get it as a very organized medical document with meaningful result, and also a very summarized result, something which can be useful for the patient as well as if they visit doctor or share it with medical practitioner. As you can see over here, Ayurlekha and the metal, it is kind of a health summary. It is very contextual, that whether the um, disease we are talking about uh, is relevant, like for example allergies or migraine or something which is there are many diseases which we have which might not be relevant, uh, and there are many uh, uh, which might be at the point when we are actually created the document. So when we go to the doctor, the whole idea is it should be smart enough to know whether it is relevant or not. And the second point is it actually brings down a lot of documents and creates a contextual in a correct time frame, a very contextual result in a very chronological order. And also, if any documents, if you look at it, it should be something very useful. This is the tech stack and architecture, and I have tried to fine tune MedGamma, but the Google Gamma library, and I'll just walk you through the application before and after training. So I have taken a application which so this is an application which is just running Google Gamma 270M model. It is a very small model, just 300 400M model. Why I have selected it is because we can run it on edge devices. If I do a very fine tuning of this model on medical data set, we can create a GGUF of this model, which we can even run it on edge devices, and we don't have to even go to the server. So users entire data remains there in the users. The privacy will be not a concern, because in medical data generally it's a concern. The model will be running on on the patients or on the customers devices itself. Just quickly take a demo. Let's say this is the question I copied from ChatGPT to ask if it's a relevant medical document. If you look at it here, which antibiotic is the drug of choice for syphilis? And the answer is this is not tuned model, so it's kind of giving some kind of good result. But let's see what it does. It is trained specifically on the medical data, and this gives a much better result. Benzathine, penicillin. This is what Google says. Then I'll look for this question. Identify a 4-year-old is presented with fever. I again give it to this particular model. Send it. The fever in patient is drunk. His blood pressure is very helpful concern. Oh, so it is giving some random result. Let's see what it gives. So it gives meningococemia, which is what Google is saying. The result is pretty good. So I'll just walk you through the code of this. This is the code. I have just created a notebook, used unsloth for faster fine tuning, converted the chat mod, took the chat template of Gamma, and then used Hugging Face data sets to get the data set of medical over reasoning SFT. It has a very good complex chain of thoughts, which actually gives the result much more purpose and details, and the thinking is there. We will just map it to the format which is required in the directly user and assistant in the conversation format, as we chat in that way, and then to make it converted into the chat template, we are using it this way, so that if you look at it, look at here, the text, this is the start of turn, end of turn, these all are added in the template. This helps it brings it in the correct training format. We are using TRLS trainer. Initially I did it for 100 steps, but once I found the result is fine, I ran it for the entire one epoch, and then trainer.train basically does the training. I've run it for all the training steps. It ran for not a very long time, for the data set was not big enough. And then I saved the pre-trained model and then pushed it to um, Hugging Face, and then created the space running on that. This is the this. I'll also walk you through the application, actual real application. So this is the video for that. If you look at it, the user is had logged in. Then this is the place where this is the home screen where scan document is there. The user clicks on the scan document, and that's it. It selects the patients. It opens up the camera. It actually captures the document. That's it. The document, even if it is not very uh, mm, clear, the result is quite decent, because in the recent time um, OCRs have been pretty good. And this is the multimodal, and it is very good in the result. I have actually ran, I have used Quen 2.5 VLM for doing the multimodal part. And so this is, as I was saying, it creates a JSON, and then it has the right metadata. And then if you look at it, it is specifically for each document. Even the text, which is the heading generated after it has analyzed the document. Um, After that, we also have something called Ayurlekha, which is the summarized format which I was talking about. It has history, conditions, medication, lab test, if it is there, and it generates and pushes from the data. This is the entire result we can see here, and then I'll just give a very quick walkthrough of the code of this. I've used uh, TSPy. It is a very good programming library from Stanford, which actually does very good for prompting, and it has uh, it has a good way of because we think in structured way, the result becomes much easier when we are actually building it. It has a very structured of writing signature modules. So signature is basically what the output you want, very similar to what we have in Pydantic AI. um, we can actually create structures same way we actually work. If you look at it, we can use typing module as well. So it is very similar to what we um, when we are actually using CRUD operations, we also think in this way. If we have used fast API, we'll see that it is very much similar in the form of schema, and so it gives us some, it becomes easier for us to think in that way. Signature is what we want, and when what we want, each field, what it is, the description is what makes it very interesting. If we have anything, if, it actually takes into the consideration what description you have given in the field, so that when LLM is generating it, it takes into the consideration of that. If you look at the modules, it is the brain of this. It is something like chaining we have in LangChain, where we can actually take the result of one, give it to the next. If you can see here is I have even given it a good grounding by verifying the medicines, whatever is extracted from the images, because it might not be very accurate because it's a um, doctor's written prescriptions. But once the output is generated, we actually verify it using search tools, and we can even create very specific models, which for medicine I haven't thought of doing it even, and planning to do it in the next step. um, in the Indian context, I can actually pull out all the medicine and then verify against it to know that whether it is right or not with the tool. Um, I'm also doing verifying the different, comparing different analysis module. It means basically uh, there are multiple documents. I'm comparing and then giving a final summarized format so that if it is repeated or what kind of document is there or whether it is making any sense in making the history, which data we should take it. I'm also using um, a mem0 because at one point I found that the memory is very important. So the um, mem0 is actually helping me to keep the relevant memory for each patient, and it removes which is not required. So it is very useful in giving a very coherent result. Then there is another main applications which is basically a React Native application, and I have even I've used Expo for it. The React Native application which can run in both. I have the APK also generated for it. Um, so yes, this is the final application. Thank you.